今天我想谢谢。今天我想介绍我们的小小的实验，用动画学习物理，但是我的中文没有很好，所以我讲英文，不好意思。So let's get started. Before starting, I want to thank my TES, teaching assistants, Terry, Darian, and Angel. They are very, very helpful for this mini project. And also, I want to thank MOE and NTHU Center for teaching for their support. Okay, let's get started from the motivation. Okay, I want to introduce you, I want to show you our daily life at NTHU. Okay, at the beginning of the physics class, it's like this. Students are very live and they're looking at the teacher, but in 10 minutes they will be like this. This is our common problem. Even in this meeting, I saw some students. So my motivation is this. So how do we keep students motivated during a physics class? Then our answer in this experiment is using anime, because students like anime, and while watching anime they don't sleep. And then maybe they focus on learning physics, so let's do it. And this is a result of a questioning at the end of the semester. But here, I ask students, do you like watching anime? And 82% of students say yes. There are many students here, right? Do you like students? Do you like anime? Yes? Oh, okay. Many people. Okay, that's good. 老师也喜欢动画。Good. Okay, so then actually this is not limited to anime, but the movies in physics are very well experimented. For example, at the University of North Carolina, there's a physics class titled From the Matrix to Mission Impossible, Physics in Film. That sounds very interesting. And also at Yale, there's a physics class called Movie Physics. And also Charleston College, there's a class called Apocalypse to Warp Drive, Physics in Film. So these classes exist overseas. Why not in Taiwan? And actually, I tried to use movies in the last semester in my physics class. Then it was a good success. Students like this experiment. This is one example. This is Indiana Jones avoiding a nuclear explosion in a refrigerator. So this is refrigerator, and there's a nuclear explosion happens, and he's inside and he survived. Do you think this is true? Can you survive a nuclear explosion in refrigerator? And one student interested in this, and he calculated, and then he found if the refrigerator is made of lead with a thickness of greater than 6.7 centimeters, then he can survive. So this, Indiana Jones movie was not totally, it's not a lie. So it was an interesting discovery. Okay, and then in this semester, we want to continue this effort using anime. And then I gave an assignment to students that please explain a physical anime scene using physics equations and actual physics. So so these are topics or animes that the students have chosen. Do you know many of them? I actually only know half of them, but some of them I know, like the Doraemon or Detective Conan. New ones, maybe I don't know. Okay, then for I want to introduce you some example of a good student presentation. So first one, in this Detective Conan scene, someone was killed in this portable toilet. In a way, so the bad guy burned these cans of butane gas, 4 of them, they burned. And then the air pressure inside the portable toilet decreased. So then water came in, and then this guy got drowned. Is this possible? Is this true? So this student, okay, first of all, when I showed the movie, everybody woke up, right? So this is one of the benefits or purposes of this experiment. Then so this student, is this true? The question, and then she actually calculated. So she tried to burn these 4 cans of gas, and they calculate how much air pressure is going to decrease, and then she found out that air pressure only, the water is going to come up only 35 centimeters. So that's not enough to kill a guy in a toilet. So that's actual physics. And this is another example. He talked about this ultra stopwatch. So this is diamond stopwatch, and if you push the button, then everything, the time freezes except you. Okay. Then it was interesting. Well, of course, that's impossible. But he had a very interesting viewpoint that so this is against the Heisenberg uncertainty principle, because all the particles of position cannot be precisely determined, right? So even if you stop the time, you cannot stop everything, and it's against the Heisenberg uncertainty principle. And furthermore, we see the light. We see the object because the light is coming from the object, right? So if everything freezes, you cannot see object. So he argued that as soon as you push the button, all blackouts, total blindness. That's a good point, I thought. I never thought in this drama in this way. And then lastly, he argues also that temperature is going to be zero, because our temperature is a motion of a particles, right? And if the particle stops, the temperature is going to be zero. So that's what he argued. That's, I think, interesting discussions. Okay, and at the end of the class, I also asked students to make a Kahoot quiz about their presentation. And I think this is a very big success, because when we have a quiz session with everybody in the class join online and try to answer these questions, they're more focused and no one's sleeping when answering the questions. So this is one example question that in the public portable toilet scene in a detective corner, why can't the burning cans create enough suction to drown the person inside? And then there are 4 choices. Do you know which one is the answer? It may be difficult to read because it's a white font. But the answer is, in this case is this yellow one, because the internal pressure decrease is not enough. That's the answer. And then we play this quiz. We have eight questions at each time. And then we have a little bit of competition. And then this is a result. And then we see who is the number 1. And then this is one student is number 1, and I'm a professor, but I'm here. It's difficult to be number 1. Some students are smart. Okay, but then there was a very good interaction in the class during this quiz. So it was very. I think this Kahoot session is very good. So this is again result of the questionnaire at the end of the semester, and then there's more interest can be a Kahoot, and then 81% of students said yes. And then actually this helps students to focus on a subject as well, because students know that there's a quiz session at the end of the class, right? Mm-hmm. So they focus very much on the contents of the other students' presentation, because this might be in a quiz, right? So this okay. So it was good to keep student focus, I think. And then, okay, I want to show more questionnaire results. 94 students answered. And then motivation increased by using Animate, and then 83% of students said yes, so that's good. And then, okay, I think this is a very good point. So every time students make presentation, I try to give them a little advanced suggestions to explore more deeper into the subject, because if I ask students to freely choose a subject and present, they tend to present only what they know. Mm-hmm. They don't present something they don't new to them. So I try to encourage them to present something newer or something deeper. So that was, I think, a very important role of me. And then, yeah, interaction was very good because using anime and also Kahoot. Oh, okay. And the students' comments, this came out just 2 days ago, was very favorable. So one student said, "This is my favorite physics class ever." The report topic was fun and interesting. Another student said, "연 최종 방식 우리 회전 연주." It's very interesting. And then also, professor is very enthusiastic about materials and activities in the class. That's good. I really enjoyed this course. I'm not just picking up good comments. Most comments are very, very favorable. Okay, then it's time, so let's summarize. So I think anime helped students to increase students' motivation because students like anime and then no one sleeps. Then Kahoot quiz, but I think it's also very useful to increase interaction among students and in the class. And then one lesson is, I think my very important role to give them advanced suggestions so they can learn something new. Okay, I stop here. Thank you very much for listening.
Thank you, Professor.
Oh, it was off?
Thank you, Professor Tomo, for the wonderful talk. It's really inspiring. So, any questions? Please.
Yeah, thank you very much. So I also teach physics in university, and actually I was inspired by your last project. So you teaching physics using movies, and I tried last semester.
You tried?
Yeah, I tried. But so that's the question I want to ask. So like, what's the time allocation for you to like for my class? Because I just like it's my first try, so I let them do in a 1 week. So like I have 2 hours. So all groups need to present and finish their presentation within the 2 hours.
Right.
And I have quite many students. I have 60 students, and I do in groups, and I have like 10, 11 groups, and then when they finish, it's like just beyond 2 hours. And I'm just wondering, so what are the presenting times for them, and then what are the weightings for these their talks, and then the quiz, you mentioned the quiz afterwards. So what are the weightings of that, and then how do you evaluate the task allocation among the members, in the groups,
So the setup is that so my lecture is very boring, right? So I assign groups, one group or two groups, every week, every time lecture. So actually at the beginning of the class, every class, we have one group of students presenting anime. And then after they finish, I give my lecture so that students have a different atmosphere. Then what's the other question?
The weighting, how much portion of the grades, the grading.
Grading is a presentation. Actually, presentation. Each student present one scene in a very short 6 minutes of time. They have only very little time because I also have many students. And then presentation is like half of the grading, and then they also need to submit a report about this. That's also half the grading. That's how I do it.
And then the quiz counts as well.
Quiz, I give top students, the number one student, I give top students bonus point, only 1 point, but then so students are very, enthusiastic to get another 1 point yet.
Thank you.
Okay, thank you for a good question.
Any other questions?
Thank you for that. I have one comment for your suggestion.
Thank you. Okay.
Why don't you make the students' presentation to the public space and make an archive and make it everyone can see? Because rather than something told by teacher, the friend or something learned and presented by students should be more powerful.
That's a very good point. Yeah, I totally agree. Some student presentations are excellent, so it'd be nice if broader audience can see it. However, there's a little bit of privacy issue. Yeah, so to make it public, I need a consent from students. So so it's a little complicated. I cannot just make it public, I think.
So I think time is up. So
Thank you very much.
Let's thank our speakers for this session.
Thank you very much. Thank you so much, too.
For other professors who like to try physics,
Yes.
I was wondering, do you have any advices for them, like how to get started, or like what kind of support do you need to provide to students?
Well, I know this is very easy setup. So
What is this? I want to stop the record.